Hello, my name is Sergey Nosov. Today we are going to explore Spec Driven Development, an emerging methodology that addresses some fundamental challenges we face when working with AI coding assistants. Before we begin, I want to set expectations. This is not a hype session. We will look at both the genuine benefits and the honest limitations of this approach. Some of you may find it valuable for your work. Some of you may decide it is not for you. Both outcomes are completely valid. I also want to acknowledge that we have engineers at various experience levels. Whether you have been coding for 6 months or 20 years, you will find value here. The concepts are accessible and we will focus on practical application rather than theory. I start with this quote from Alan Kay because we stand at an interesting moment. The best way to predict the future is to invent it. AI coding assistants have moved from novelty to necessity for many teams. But here is the challenge. We are inventing new ways of working with these tools in real time, and not all approaches work equally well. Some approaches excel at rapid prototyping, others fall apart when we need production quality code that meets our standards of quality, security, and maintainability. Spec-driven development represents one attempt to structure our collaboration with AI in a way that scales beyond quick prototypes. Today, we will explore whether it lives up to that promise. Let me outline our journey for today. We will start by examining the challenge with unstructured AI coding, what people are calling vibe coding. Then we will explore what spec-driven development actually is and how it works. We will compare it to methodologies you already know, TDD, BDD, Waterfall, and big design upfront. We will look honestly at both the benefits and the limitations, including some sobering research results. Finally, we will discuss when and how to use this approach effectively. Fair warning, I am not here to sell you on this methodology. My goal is to give you the information you need to make informed decisions about whether and when to use it. We will look at successes and failures with equal honesty. Let me start by naming the problem. In February 2025, Andrei Karpathy coined a term that resonated with many developers: vibe coding. This describes how many of us have been working with AI assistants. We have a conversation with the AI. We describe what we want conversationally. It generates code. We look at it and think, yeah, that seems about right. We paste it in, we move forward. This approach has real advantages. It is fast, it is flexible, it keeps you in the flow. For prototyping or exploring new ideas, vibe coding can be incredibly productive. But here is what happens when you rely on vibe coding for production systems. The AI forgets important context between sessions. Different team members prompt the AI differently and get inconsistent implementations. There is no alignment mechanism to ensure we are all building the same thing. And when quality, security, and maintainability matter, which they do for production, vibe coding breaks down. I want to be clear. I am not here to criticize vibe coding. It is a legitimate tool for certain contexts. But we need additional approaches for the work that demands more structure. Let me make these concrete. Vibe coding is excellent for prototyping and exploration. The problem emerges when we need production requirements. On the left side, you see what production code typically requires: consistent architecture so the system holds together, security compliance to protect users, team alignment so we are not duplicating work, maintainable code that others can understand, quality standards that meet our bar, and documentation for the next person. On the right side, you see what wipe coding typically delivers. Whatever seems right at the moment, whatever the AI remembers from our conversation, whatever the prompt said, code that looks good on the surface, fast iteration, and maybe some comments if we are lucky. The gap between these two columns is where we feel pain. We need a structured approach when the stakes are higher than a quick prototype. Now, let us explore what spec driven development actually is. We will build up the concept piece by piece. At its core, spec driven development flips the traditional relationship between documentation and code. In SDD, specifications become the source of truth, not the code. Code becomes a derivative artifact that can be regenerated from the specification. Think about what this means in practice. You write a specification that describes what you want to build and why. That specification is structured enough that AI coding agents can consume it and generate production quality code. When questions arise or changes are needed, you modify the specification first, then regenerate the affected code. In traditional development, we write code first and maybe document it later. The documentation almost always drifts out of date because the code is the truth. In SDD, the specification stays current because it is the source from which code is generated. The specification is the truth. SDD rests on 4 key principles. Let me walk through each one. First, specification as source of truth. The specification sits at the top of the hierarchy. When questions arise about what the system should do, you consult the spec, not the code. The code is an implementation detail. Second, intent over implementation. You focus on what the system should do and why it should do it, leaving how it does it to AI agents. You operate at the level of intent rather than mechanics. Third, living executable artifacts. Unlike static documentation that becomes outdated, specifications in SDD evolve continuously with the project. They remain version controlled alongside the code, and they actively drive code generation, making them truly executable. Fourth, structured workflow with checkpoints. Humans validate at explicit points before proceeding to the next phase. You maintain control and oversight while delegating the mechanical work of implementation. SDD follows a structured 6-phase workflow. Let me give you the overview and then we will dive deeper into a few phases. Phase 1. Constitution. This is your project's DNA, the non-negotiable principles and standards that guide every decision. You write this once, and AI agents reference it for every feature. Phase 2. Specify. You write high-level requirements, what you want to build and why, without technical implementation details. Phase 3. Clarify. The AI asks structured questions to resolve ambiguities and document assumptions. This is where you discover you and your product manager had completely different mental models of user notifications. Phase 4. Plan. Now we get technical. Architecture choices, data models, API specifications. We define how to implement the requirements from Phase 2. Phase 5. Tasks. We break the plan into specific actionable tasks with dependencies and execution order clearly marked. Phase 6. Implement. AI agents execute tasks either sequentially or in parallel, and you review focus changes at each checkpoint rather than reviewing 1,000-line pull request all at once. The critical principle here is human validation at each checkpoint. This is not autopilot. This is not set it and forget it. This is structured collaboration between humans and AI. Let me show you what a constitution looks like in practice. This is the phase where you codify your project's architectural principles. Here is a simple example. Under coding standards, we specify TypeScript with strict mode enabled, functional programming patterns preferred, all public functions require JSDoc comments, and maximum function length of 50 lines. Under architecture principles, we specify RESTful API design following OpenAPI 3.0, repository pattern for all data access, feature-based folder structure, and no direct database calls from controllers. Under tech stack constraints, we specify Node.js version 20 or higher, Express 5, Postgres 15, React 18 with TypeScript, just for testing with minimum 80% coverage, and no unmaintained dependencies. The beauty of the constitution is you write this once, and then AI agents apply these principles consistently across every feature they generate. You no longer need to remind the AI in every prompt about your coding standards. You no longer get inconsistent implementations across your code base. The specify and clarify phases work together as a pair. In specify, you capture intent without getting into implementation details. You write user stories, business requirements, acceptance criteria, edge cases, success metrics. You focus on outcomes, not mechanisms. Then, in clarify, something interesting happens. The AI helps you discover gaps in your specification. It asks structured questions, it validates assumptions, it checks for completeness. It helps you discover edge cases you had not considered. It resolves ambiguities before anyone writes code. This clarification phase is where a lot of value emerges. How many times have you been deep into implementing a feature and realized that you and your product manager had completely different mental models of what user notification, for example, meant? Or that the front-end engineer, back-end engineer, and designer all had different assumptions about how something should work? The clarification phase surfaces these misalignments before they become expensive. You discover you were building different things before anyone writes code. Let me walk you through a realistic example so you can see SDD in action. Imagine your product manager comes to you and says, "We need a notification system so users know when important events happen." Phase 1. Constitution already exists. We have established our TypeScript, React, Postgres stack with RESTful APIs and testing requirements. We now move to phase 2, specify. We write down what and why. Here is a simplified version. Purpose. Users need timely awareness of account activity and system events without checking manually. Then we capture user stories. As a user, I want notifications when someone comments on my content. As a user, I want to control which notifications I receive, email, in-app, or both. Notice what is not in here. There is no implementation code. There is no database schema. There is no API endpoint definition. This is pure intent, what the system should do, and not how it should do it. Now we reach the clarify phase, and this is where things get interesting. The AI asks questions to expose gaps in our specification. How long should notifications be stored? What happens to notifications for deleted users? Should notifications batch during high-volume periods? How do users access notifications history? What notification types need immediate delivery versus batching? These are excellent questions. Without the clarification phase, different team members would make different assumptions about the answers. The backend engineer might assume notifications live forever. The product managers might assume 30-day retention. The compliance person might be worried about data retention policies. After clarification, we update our specification. We document that notifications store for 90 days, then archive. We specify that all notifications delete when the user account closes. We define delivery strategy, security alerts and mentions deliver immediately, while comments and likes batch hourly. Now, everyone on the team has the same understanding before anyone writes a line of code. Now we move through the final 3 phases more quickly. In phase 4, plan, we get technical. We specify a PostgreSQL table for notifications with columns for ID, user ID, type, data, read status, and created at timestamp. We define REST endpoints, get for fetching notifications, patch for marking them as read. We plan a background job for the notification delivery service. We decide to use WebSocket for real-time in-app delivery. In phase 5, tasks, we break this down into specific actionable work. Create database migration, implement repository layer, build REST API endpoints with OpenAPI spec, create notification delivery service, implement WebSocket notification channel, build React UI component, write integration tests. In phase 6, implement, AI executes each task. Here is the crucial difference from traditional AI-assisted development. You review focused changes one task at a time, instead of reviewing a massive pull request with thousands of lines covering the entire feature. You review incremental changes. Database migration in one PR, repository layer in another, API endpoints in a third. Each one is focused, reviewable, and validates against the specification. Now that you understand what SDD is, let us position it relative to methodologies you already know. This will help you understand when to use which approach. Many of you are familiar with test-driven development or behavior-driven development. Let me show you how SDD relates to these. Test-driven development, TDD, operates at the unit or function level. You write a failing test, write minimal code to pass it, and then refactor. The primary artifact is unit tests. TDD asks, are we building it right? Behavior-driven development, BDD, operates at the user behavior level using given, when, then scenarios. The primary artifact is behavior specifications. BDD asks, does it behave correctly? SDD operates at the feature or system level. You write specifications that guide AI to generate both code and tests. The primary artifact is the specification itself. SDD asks, are we building the right thing? Here's the key insight, and this is important. These are complementary, not competing. You can use SDD for high-level feature specification architecture. You can use BDD for end-to-end behavior validation. You can use TDD for unit-level correctness. They work together as a stack rather than as alternatives you must choose between. Now, let us address the elephant in the room. When people hear about spec-driven development, a common criticism emerges. This is just Waterfall with better branding. This criticism deserves a serious answer. Let me show you where SDD actually differs from Waterfall. Waterfall has sequential phases with gates. Once you move from requirements to design to implementation, you cannot go backward. You do exhaustive upfront design, trying to specify everything before writing any code. It can be months before you see working software. Change is expensive because everything is already planned. You validate at the end, build it all, then see if it works. SDD has iterative phases with checkpoints. Loops are not only allowed but encouraged. You do sufficient detail, not exhaustive upfront design. You capture intent and discover details iteratively. You see code within hours or days, not months. Change is relatively cheap. You update the specification and regenerate the affected code. You validate continuously at each checkpoint. The concern about Waterfall is valid. SDD done poorly can feel like Waterfall. The difference is continuous validation and iterative refinement. You are not trying to specify everything perfectly before starting. You are clarifying intent, then discovering and adapting as you go. Another common question: is this big design upfront in disguise? Let me clarify what BDUF actually means. BDUF is the attempt to design every detail before implementation, assuming you can predict all requirements upfront and get them right the first time. Here is how SDD differs. Specifications in SDD evolve. They are not carved in stone. You capture intent, not every implementation detail. If your specification describes user notifications should use WebSocket for real-time delivery, that is implementation detail creeping in. Better to say users should receive notifications immediately when important events occur, and let the planned phase determine whether that means WebSocket, server-sent events, or polling. Specifications are living documents that change with learning. The AI helps discover missing requirements during clarification. You can start with minimal viable specifications and expand them based on what you learn during implementation. Think of it this way. BDUF says, design everything now and get it perfect before coding. SDD says, clarify intent now. Discover implementation details iteratively. So, when should you use each approach? Let me give you a practical decision framework. For a quick prototype where you are exploring ideas, use vibe coding. Speed beats structure. For a small bug fix, use direct coding with TDD. The overhead of SDD is not worth it. For a complex feature with multiple people involved, use SDD plus BDD plus TDD. You need alignment and quality. For a novel algorithm that requires deep technical expertise, use direct coding with TDD. Human expertise matters more than structure. For legacy modernization, where you need to capture business logic for a building, use SDD. The specification becomes your documentation of what the old system actually does. For rapid exploration, where you are learning, use vibe coding. Learning matters more than structure. For regulated industries where you need audit trails, use SDD. The specifications provide the documentation you need. The key is strategic choice based on context, not ideology. Do not be the person who insists on using SDD for a 3-line bug fix. Do not be the person who uses vibe coding for a complex feature with compliance requirements. Match your methodology to your context. Now, let us look honestly at the benefits. Where does SDD actually deliver value? First, let us talk about how SDD helps AI agents work better. Specifications provide refined context. The AI gets what it needs without being overwhelmed by irrelevant details. Clear requirements with documented edge cases reduce hallucinations and drift. The AI is less likely to make things up when it has clear guidance. Specifications provide persistent memory. They survive across coding sessions. If you are working on a feature across multiple days or weeks, the specification maintains context and the AI remembers it rather than forgets. Specifications enable iterative regeneration. When you discover your data model needs adjustment, you update the specification and regenerate the affected code. You do not need to manually refactor everything and hope the AI remembers your intent. Here is a real example. A team building an identification system discovered their AI assistant generated 3 different data models across 3 different sessions when using vibe coding. Each session, the AI forgot what they had discussed previously and made different design choices. With SDD, the specification anchored consistency across all sessions. Second, let us talk about team collaboration benefits. Specifications compress alignment. Instead of having 6 different conversations with 6 different people to ensure everyone understands the requirements, everyone reads the same document. Shared understanding emerges more easily. Specifications enable parallel work. Backend engineers, front-end engineers, and designers can work simultaneously because the specification provides clear boundaries and contracts between components. Specifications preserve institutional memory. When a senior engineer leaves the company, their knowledge about why certain decisions were made remains in the specifications rather than walking out the door. Specifications prevent surprises. Misalignments surface during specification review, not during demo day when the product manager sees the feature for the first time. Here is a common scenario. A product manager, a back engineer, a front engineer, and a designer were all building a notification system. They discovered during implementation that they had 4 completely incompatible mental models. The PM expected email notifications only, the backend engineer built in app notifications only, the front-end engineer designed for both with complex UI, the designer expected push notifications. A single specification review would have revealed these 4 different approaches before anyone wrote code. Third, let us talk about code quality benefits. Structure enables early discovery. Misunderstandings surface before implementation when they are cheap to fix rather than during refactoring when they are expensive. Specifications force integration clarity. You have to think about how your new feature fits into the existing system. You cannot wave your hands and say, "We will figure that out later." Specifications enable focused reviews. Instead of reviewing a 1,000-line pull request that touches 30 files, you review incremental changes that solve specific problems. Each review is focused and traceable. Specifications provide compliance trails. If you work in a regulated industry, healthcare, finance, government, the specifications provide audit documentation showing what you intended to build and why. Where teams actually track metrics, they report some measurable improvements. Cycle times get cut by roughly a third. Code review time drops significantly. Pull request throughput increases notably. But I want to emphasize qualitative feedback over precise numbers, because the quantitative feedback is more universal. Engineers consistently report less rework from misunderstandings, better code consistency across the team, and easier onboarding for new team members who can read specifications to understand system intent. Now, let us talk honestly about the limitations, because SDD is not a silver bullet. and pretending otherwise does not serve anyone. First, let us talk about technical limitations. AI agents remain unreliable. Even with detailed specifications, agents frequently ignore parts of what you specified. They follow some instructions but not others. This is unpredictable. There is non-determinism. The same specification produces different code across multiple runs. This makes the spec as source approach unpredictable. You cannot treat specifications like source code that compiles to identical binaries every time. AI agents sometimes over-engineer. They follow your constitution rules too rigidly and create unnecessarily complex solutions. You say, follow functional programming patterns, and they turn a simple function into an elaborate composition that nobody can understand. There are workflow mismatches. Tools can be inappropriately sized for the task. Here is a real example from ThoughtWorks. AWS Kiro turned a simple 3-line bug fix into 4 user stories with 16 acceptance criteria. Sometimes you need a screwdriver, not construction equipment. SDD is not suitable for all work. UI-heavy visual design does not benefit from non-visual specifications. Novel algorithms requiring human expertise do not fit this model. Rapid prototyping gets slowed down by overhead that exceeds the benefit. Now, let us talk about process and people challenges, because these are often harder than the technical challenges. Specification writing is a different skill from coding. Developers who are incredibly efficient at writing code often struggle with formulating precise requirements in prose. It requires practice and a mindset shift. There is an initial productivity dip. It takes 3 to 6 months of learning before productivity gains appear. During that learning phase, you will feel slower. This is normal, but 67% of teams experience this dip, and it affects morale if you are not prepared for it. Training takes time, 8 to 12 hours over several weeks. That is the time away from shipping features. Developer resistance is real. I want to read you some actual objections I have heard. Writing specs takes longer than just coding. This breaks my flow state. I lose creative control. And here is the reality behind those objections. Initially, writing specs does take longer than coding. It improves with practice, but there is a learning curve. The flow state concern is legitimate. This is a different flow, not a broken flow, but it feels uncomfortable at first. The creative control shifts from implementation level to intent level, which some developers experience as a loss. Now, let me share the most rigorous research we have on AI-assisted development effectiveness. This is from the Meta study in 2025. 16 experienced developers, 246 tasks in mature projects. High quality standards, not quick prototypes. This was production code with requirements for documentation, testing, and linting. Here is what they found. Developers using AI tools were 19% slower than developers working without AI. Let it sink in. Not faster, slower. 19% slower. This directly contradicts the predictions. Before the study, the developers themselves predicted they would be 24% faster with AI. Expert forecasters predicted 38 to 39% faster. Everyone was wrong. Now, context matters here. This study involved high-quality standards, many implicit requirements, mature codebases with complexity and constraints, and experienced developers who already had efficient workflows. Other studies show gains for specific use cases. Boilerplate generation is 50 to 80% faster with AI. Documentation writing is 60 to 70% faster. Code translation between languages is 40 to 60% faster. But the meta study is important because it measures the kind of work many of us actually do, maintaining and extending mature production systems with quality standards. So, how do we make sense of these mixed results? AI helps significantly with boilerplate code generation, documentation writing, code translation between languages, repetitive patterns, and helping junior developers learn. AI struggles with complex problem solving, meeting high quality standards, fitting into experienced developer workflows, working with mature complex code bases, and making architectural decisions. Here is the key takeaway. SDD works best when the value is in alignment and structure, not just faster coding. If you adopt SDD primarily because you think it will make your code faster, current evidence suggests you may be disappointed. But if you adopt SDD because you need better alignment across your team, more consistent architecture, compliance documentation, or better context management for AI agents, those are the areas where value emerges. Now let us get practical. When should you actually use SDD and how should you adopt it? Here is your decision framework for when use SDD. Use SDD for complex features in existing systems where architectural constraints matter. For multi-stakeholder projects where product, engineering, design, and legal all need alignment. For multi-day or multi-week efforts where context management across sessions matters. Where high-quality standards are required and cannot be compromised. In regulated industries needing audit trails for compliance. For legacy modernization projects where we need to capture business logic. For distributed teams where alignment is challenging. Avoid SDD for rapid prototyping and exploration where speed trumps structure. For small bug fixes where overhead exceeds benefit. When requirements are rapidly changing and spec maintenance becomes its own burden. For novel algorithms needing deep human expertise. For single developers working on familiar code where there is overhead without collaboration benefit. During high-pressure immediate deadlines where there is no time for learning, for UI-heavy visual design work where non-visual specs do not help. Here is the key question. You should ask yourself, does a prompt specification reduce total effort for this specific task in this specific context? If yes, consider SDD. If no, use a simpler approach. Let me orient you to the tools and landscape. 3 major platforms emerged in 2024 and 2025. GitHub Spec Kit is open source. It is a CLI toolkit supporting more than 15 AI agents, including Copilot, Cloud Code, and Cursor. It features the 6-phase workflow we discussed with the constitution concept. Best for enterprise teams with established workflows. Status, active development, but still experimental. AWS Cairo is a VS Code extension with a 3-phase workflow based on Amazon's internal PRD process. It features a steering concept, essentially a memory bank for consistency, and agent hooks for automated quality enforcement. Currently waitlist only due to high demand. Best for production applications with AWS integration needs. Tessel framework is in private beta and takes the most radical spec as a source approach. Code is marked do not edit. Only specifications are maintained by humans. Best for cutting edge early adopters willing to experiment with bleeding edge approaches. Supporting tools include OpenAPI and Swagger for API specifications, MCP servers for enhanced AI context, and various CLI agents like Continuo.dev, Aider, and Amazon Q Developer. If you decide to experiment with SDD, here is a practical roadmap. Start with a pilot phase lasting 1 to 3 months. Select 3 to 5 volunteer developers, enthusiastic people with a supportive team lead. Choose 3 to 5 medium complexity features. This is important. Do not choose high-pressure deliverables for your pilot. Choose work where there is room for learning. Use a single tool. GitHub Spec Kit or Cairo are recommended for starting. Do not try to evaluate multiple tools simultaneously. Maintain traditional development as fallback option. If SDD is not working for a particular task, developers can fall back to familiar approaches without feeling trapped. Track metrics: time spent, quality outcomes, team satisfaction. You need data to evaluate whether this is working. Phase 2 is team scale over 3 to 6 months. Roll out to the full team of 10 to 30 developers. Expand to 30 to 50% of work, not 100%. Develop internal best practices and prompt libraries. Create champions and mentors for peer support. The success factors are critical. You need executive sponsorship and visible leadership support. You need enthusiastic early adopters as champions. You need patience. Allow 3 to 6 months of learning curve before evaluating ROI. And you need flexibility. Maintain traditional development as an option. Here are the best practices from teams who have adopted SDD successfully. Start small. One feature, not entire applications. Do not try to rewrite your entire codebase with SDD. Pick one feature and learn. Include tests from day one. Quality is part of the specification, not an afterthought. If your specification does not mention testing requirements, you're doing it wrong. Version specifications with Git. Treat them like code. When you update a spec, commit it. When you review a spec, use your code review tools. Iterate on specifications. They need refinement based on how AI agents actually behave. Your first spec will not be perfect. Learn and improve. Share learnings. Build an internal knowledge base of what works and what doesn't. Successful prompt patterns, common pitfalls, architecture decisions that work well. Be patient. 3 to 6 months before ROI appears. Do not evaluate success after 2 weeks. Most important, match method to task. Not every task needs SDD. Use vibe coding for exploration. Use SDD for production features. They are complementary tools, not competing religions. The moment you become dogmatic about always using SDD or never using SDD, you have lost the plot. Let me bring this together for you. SDD addresses real problems. It provides structure for AI collaboration. It creates alignment mechanisms for teams. It generates compliance documentation for regulated industries. It enables focused code reviews. It preserves institutional knowledge. But SDD has real limitations. It adds overhead for simple tasks. It requires new skills that take time to develop. It relies on immature tooling that has reliability issues. It may slow experienced developers in some contexts. And if applied dogmatically, it risks recreating waterfall problems. The practical approach is to use SDD strategically where structured planning provides clear benefit over exploratory coding. Choose based on context, not ideology. The future involves both vibe coding and spec-driven development as complementary techniques in your toolkit. You will use vibe coding for rapid prototyping and exploration. You will use SDD for complex features with high-quality requirements. You will use direct coding with TDD for simple changes. You will choose based on the work at hand, not based on what methodology you personally prefer. Let me leave you with 7 key takeaways. 1. SDD emerged in 2024 and 2025 as a structured alternative to unstructured vibe coding for AI-assisted development. 2. Specifications become the source of truth. Code is derivative and can be regenerated from specs. 3. SDD follows a 6-phase workflow with human validation at each checkpoint. This is not autopilot. 4. SDD is not waterfall or big design upfront. It is iterative with continuous validation and specs that evolve. 5. SDD works best for complex features with multiple stakeholders and high-quality needs. It is not universal. 6. Expect a learning curve of 3 to 6 months before productivity gains appear. Do not give up after 2 weeks. 7. This is a strategic tool, not a universal solution. Match your methodology to your context. I want to close with this reminder. Start small, iterate, and match method to context. The goal is better software, not perfect processes. Now, I would love to open up this for questions and discussion. What resonates with you? What concerns do you have? How might this fit or not fit into your current workflows? Thank you.